Short video is for anyone who wants to try automated economic reasoning but is not yet familiar with the Wolfram language. I will show the necessary basics of that language. If you already know the basics, you can get started immediately with the first get command and skip the rest of the video. Here we have a Mathematica notebook where we can input commands for the Wolfram language. Each command is put in a cell, and I'm going to start at a cell here below the title, and I'm going to start typing get. That's one of the many Wolfram language functions, and you can see Mathematica is trying to anticipate what I want to type. Functions typically have arguments, and in the case of this one, the argument will be the file that we want to get. It is out on the internet. All functions have their arguments surrounded with square brackets. Get does too. And then we'll put in the argument. In this case, it's a file names are strings, so we have to have those in quotes as well. We could hit the return key here, but what will happen, nothing will execute. We'll just get a new line. And that's because in the Wolfram language, you can put a single command on multiple lines and format it as any way you want. We could put this get command on 3 lines if we want, if I put a return character before the quote. When we want to actually execute, or as they say, evaluate the command, then we need to hit the Enter key on a numeric keypad, or say on a laptop, you hit Shift Return. And now the get function has been evaluated, and we've loaded, in this case, the economic reasoning package from the internet. Let's look at a couple of other functions. Pi is a function. It's the famous ratio of a circle's circumference to the length of its diameter. And that particular function doesn't take any arguments, so we don't need the square brackets. Another function we could look at would be the sine function from trigonometry. Maybe we'll use that together with the pi function. Sine takes an argument, namely the angle we want to use. Let's try the angle pi over 6. Again, when we want to evaluate this function, we'll use the Enter key on the numeric keypad or Shift Return on a laptop. And that function is evaluated correctly, of course. It's exactly equal to 1/2. Now, there are a lot of functions and sometimes hard to remember how they work. And Mathematica has a couple of tools for doing that. One is the information function. So it's a function called information. You could type in information and then the name of a function to be reminded of what it does. The shorthand for this is just to put a single question mark in the name of the function. And let's look at the primary function in the economic reasoning package. It's called Theory Guru. Again, we hit Shift Return. And we're given a report on how this function works. In this particular report, we see there's 2 versions of the function. One version takes 2 arguments, an assumption and a hypothesis. In the other function, you just put square brackets with nothing in there, and it fills in default assumption and a default hypothesis. So information, a question mark, is one of the tools. Another tool that we have is the template. Mathematica's templates. Again, we start with the name of a function, and we'll use Theory Guru. This time we can hit, one way to do it is to hit Control-Shift-K, or on a Mac you'd hit Command-Shift-K, and it will bring up a template. Two ways that you can start working with this function. There's a bottom one and a top one here. We'll choose the top one. And what it does is it fills in two placeholders where you need to put additional information. And there's labels on those placeholders. In the first place, we can see put an assumption. In the second place, we would put a hypothesis. It's important to remember that we use square brackets to surround function arguments. We got a function, say, the sine function. It needs arguments, and the arguments need to be in square brackets. It's tempting, if you're coming from an algebra background, to use parentheses here, and that's not going to be proper. The red is a clue to that. But the reason is that the parentheses are reserved for multiplication. Mathematica understands parentheses that you want to take what's outside and multiply by what's inside. So parentheses are just for multiplication, and square brackets are just for surrounding function arguments. Now let's move on to one of the important features of the Wolfram language, lists. Lists are formed with curly brackets, and you put the elements of the list inside, separated each one from the other by a comma. In the economic reasoning package, the main reason we look at lists because we want to have, say, lists of assumptions. So let's start with an assumption list, maybe two of them. We'll assume first that, say, the price is positive, and second, that the quantity is positive. And that's now a list, and it can be our first argument of our Theory Guru function, the assumption argument, and then we'll follow it by a hypothesis argument, which also could be a list, but we'll just have a single hypothesis here, that the product of price and quantity is positive. Notice I followed the convention of algebra here of having a space between two variables. Mean multiplication, you could put an asterisk there and it would mean the same thing. And so what the Theory Guru function will do is confirm or deny that we can conclude that price times quantity is positive whenever we assume that price is positive and quantity is positive. Of course, we know this is correct. This is an easy one, but we'll hit Shift Return and see if Theory Guru agrees. It does agree, it says true. We'll also see that we had a dashboard pop up here that can give us more information about the calculations. That's beyond the scope of what we're going to do in this video. So we'll shut that. But more important is we've made our first use of a list. Now let's look at set versus equal. These are two functions in the Wolfram language. They're different, and it's pretty important to understand how they're different. Let's start with the set command. It's used because often it's convenient to have a shorthand for lists or other long expressions so we don't have to type the expression every time. You know, maybe we had our assumptions above here, price and quantity are positive. Maybe instead of typing that list every time, we want a shorthand for it. We give it a name. It's like a pet. You can name it whatever you want. It's your pet. I'll name this pet PQ plus. And the set command, which we can indicate which is the single equal character, we'll type our list. And I'll put a semicolon at the end so that I don't see the list repeated again when I hit Shift Enter. While we're at it, let's name another pet, if you will, another shorthand. We'll call it expenditure. And that we don't want it to be a list, we just want it to be the product of price and quantity. Again, the semicolon will just suppress repeating that when we evaluate these. So we evaluate them with Shift-Enter, and now we have these two nicknames, if you will. Anytime from now on when we type PQ+, the Wolfram language will understand that to mean our list, and expenditure will be understood to mean that product. We could use this a number of ways, but we could use it in the theory guru function again. This time our assumption will be, we'll just type PQ+. And the hypothesis will type expenditure positive. This is a shorthand way of writing the same thing we had at the top of the screen here. It's easier to type and perhaps also easier to understand on a quick reading. Shift-Enter tells us that it's true. So that's a helpful way to use set. Now let's look at equals. Equals a different idea. It's a mathematical idea. It's not a process of giving nicknames. It's to say that two things are mathematically equal. Maybe we want to have, maybe we have a model that says, simple model of course, that the price is equal to 2. We would use two equal characters to indicate mathematical equals rather than set. And so our hypothesis, our assumption would be that the price equals 2. And maybe our hypothesis is that the price is larger than 1. Of course, the hypothesis follows from this simple assumption, and Theory Guru would confirm that it's true. So that's equal. Now what if we had done set by accident? This accident happens a lot to beginners. So let's just see what happens. So instead of the two equal signs, we'll have 1. This means set. What's going to happen here is that price is going to become a nickname for 2. It'll no longer be a variable. It may equal 2 in the model, but it's just a nickname, and everywhere price appears, the Wolfram language will immediately put a 2 there, because it thinks when we say price, we mean 2. So we'll evaluate that with the shift return, and we get an error. We also get the function returned back unevaluated, because our assumption is just 2. It's price, but price is 2, because we use the set command. And our hypothesis also is just that 2 is bigger than 1, which is, of course, true, but not connected to the assumption in any way. So Theory Guru has been programmed to try to detect these inadvertent errors between set and equals, and it gives this warning that says 2 is not an assumption or hypothesis. Check your use of set versus equals, and unset is needed. Okay, let's fix our mistake here, which was to use price as a nickname for 2. I'll use the unset command, because I don't want price to be a nickname for 2. And then we'll move on to our next important topic, which is Booleans versus real numbers. Let's look at another hypothesis here. It will be a list of 2 assumptions. First one will be A implies B. We enter implies with escape equals greater escape. A implies B is our first assumption. Our second one is that B implies C. Now the implies operator is not an algebraic operator. It's not used for comparing real numbers. It's used for comparing Booleans, variables that would either be true or false. A is either true or false. B is either true or false, and same with C. Mathematica and Theory Guru automatically recognize what situation applies. And here it will automatically know that unlike price and quantity, which were real numbers, representing real numbers, A, B, and C here represent Boolean variables. We'll make our hypothesis be, let's say, that A implies C. This is an easy one, of course. The hypothesis always follows from these two assumptions, and Theory Guru will confirm that with shift return. And yes, that's true. The other thing we need to know about Booleans are the and, or, and not operators. And let's use those with our price, quantity, and expenditure model. We want to make the same assumptions, that price and quantity are positive, but instead of entering the list, let's enter these assumptions with the Boolean. So we'll say price bigger than 0 and quantity bigger than 0. This is the same way of entering the assumptions. It's the same assumptions that we entered before, but entered in a different way with the Booleans instead of the lists. Let's make our hypothesis a little different this time. Maybe use the not operator. We'll say not, the not function, and inside the not function we'll say expenditure negative. So we're going to ask the Theory Guru, can we conclude that expenditure is not negative if we assume that both price and quantity are positive? Of course, the answer is yes. And we'll confirm that with the shift enter, shift return, and yes. These are all the basics that you need to be a productive user of the economic reasoning package. Let's summarize what we did here. We first looked at get, functions, information. Remember, we used the question mark there. And templates. We looked at lists. We were using algebraic operators such as greater than, less than. You can also do greater than or equal to just by putting greater and equal to next to each other. You can also do not equal with exclamation point equal. And then, of course, there was equal itself. And then finally, we did the Boolean operators and didn't mention or, but it works the same way. Put it in with the two vertical bar symbols. There was not, and there was implies.